so this is 7.2, which is this technique called completing the square. That's spelled wrong. Pretty sure. Okay, so the way completing the square works, the idea is I have some kind of ax squared plus bx plus c equals 0. You guys are used to these, right? These are all the problems in section 6.6 mostly, right? These are the solved ones. Now, if I could factor this thing, right, then I would do that, and then I would apply the zero product rule. So this is a more robust technique that works when I sometimes can't factor, right? The idea of this one is maybe best done by example. So let me give you an example. Let's say I had x plus 1 squared is 4, right? Okay, how do I solve this?
You would square root with both sides.
Yeah, I've got a technique for this, right? I could extract the roots and get some numbers for this, yeah? We may have just learned extraction of roots, but whatever, we can do it. Okay, now the problem is, maybe the person you're with is dumb, and they multiply it out, right? Because that's actually almost a reasonable step. They taught me to do something a lot like that in one of the other sections in chapter 6. So what if we FOILed this thing out? What do I get?
You get x squared plus 2x plus 1.
Okay, so I got x squared plus 2x plus 1 is 4, right? Okay, and then if I subtracted the 3 over, I'd be kind of up in this problem form, right? Okay, so maybe they did that, right? This makes sense. So now I'm wondering, okay, if I started with this problem, a second ago this was easy, right? Before some dummy FOILed it out and combined like terms. You guys see that? All completing the square is a technique for unfoiling and unadding like terms. Cool? So let's start with this one as an example. So if I started with this, I want to complete the square. On this guy. So I've got x squared plus 2x minus 3 is 0. My goal is to make it look like this again. Cool? Okay, so what I'm going to do is I'm going to start by saying, all right, the 3's in the way. I'm going to push it to the other side. Okay? So I'm going to add 3 to both sides, even though that seems kind of backwards. So I've got x squared plus 2x is 3. Cool? Now I'm going to throw a blank in both sides, because I'm going to fill it with something. Okay? The thing I'm going to fill it with is the term that I need to put there to make this thing into a PST. You guys see that? So I want to think about this whole guy here as a PST. Cool?
Is it 2?
That's 1.
It's a
1.
Wait, but it's 2 divided by.
So remember, the PST has something squared, right? Plus twice the beginning thing and the end thing, right? You guys see that?
Yeah. Okay.
So I got to think to myself, okay, if this is going to be something squared, right? I should take this middle number. All right, so I've got x, and then I'm going to add whatever this number is divided by 2. So what's 2 over 2?
1.
1. And then I'm going to take that number and what it to get it here and here.
I thought it was like multiply it by itself.
Yeah, square. So what's 1 squared?
1.
1 and 1. Why did I put 1 on both sides?
Because you do it to one side, you have to do it to the
Yeah, to keep the equation in balance, right? If I'm going to do something to one side, I've got to do it to the other. Okay, see that? Okay, so now I could FOIL this thing back out to check, right? Okay, see that? I get this thing. What's the right-hand side? 4. You guys see the little dotted arrows are bringing me from here back to here? So now I can solve this by extraction of roots, right? Cool. Should we remember extraction of roots since we just learned it? So what do I do to extract roots?
Square root of both sides.
Okay, so we plus minus square root both sides. So we get x plus 1 is
2.
Plus or minus 2.
plus or minus 2. And then what?
You get x equals plus or minus 1.
plus or minus.
Subtract 1 from both sides, right?
Yeah. And
So I
then
get x is negative 1 plus or minus 2.
So x
So x
is
is
1 and negative 3.
1 or x is negative 3. Cool. You see this? You want to try another one?